Hello, everybody. Hope everybody's having a good day and is staying healthy out there. So today we are continuing on in the polynomial unit. Up to this point, we've looked at multiplying polynomials. Today, what we're going to do is take a lesson, the first lesson on factoring polynomials. And so up to this point, we have been multiplying polynomials. And factoring, which is what we're looking at today, is actually the opposite of multiplying polynomials. And so I'll just write some notes here. So factoring polynomials is the opposite of multiplying polynomials. And so what we're trying to figure out is, like, given a polynomial, what things could have got multiplied together to result in that polynomial? And so we'll start off with the most basic type of factoring, which is factoring by greatest common factor. And just overall, I guess a side note here, factoring is one of the most important takeaways from Math 10C. You need it to be successful in any -1 or -2 stream continuing from here. So make sure you take your time, watch these videos, and please email me if you have any questions. So what we're looking at today is factoring via taking out a greatest common factor. And so when I'm taking out a greatest common factor, what I'm doing is I am either removing, and so when I say remove, what I mean is we are actually dividing out the largest coefficient. So I'm going to divide out the largest coefficient and the largest number of variables that can be removed evenly from each term. And we started looking at greatest common factor in the numbers unit by just saying, like, here's two numbers, you could do a prime factorization to figure out their greatest common factor. But hopefully some easier numbers, you can just look at them and determine what the greatest common factor is. So just a basic example before we look at greatest common factor with polynomials is, so if I give 20 and 65, I should realistically be able to look at this and say what the greatest common factor is. I know off the top of my head, numbers that multiply to 20 are 1 times 20, 2 times 10, and 4 times 5. Well, 20 is not going to divide evenly into 65. 10 doesn't divide evenly into 65, but 5 does. And so I know 5 is going to be the greatest common factor between 20 and 65. Take a second for yourself here and say what the greatest common factor between 28 and 14 would be. So I always start with the lower number. And generally what I'm going to do is say, like, can this lower number go evenly into here? Because 1 times 14 are factors of 14 and 2 times 7. Well, 14 actually divides perfectly into 28. So the greatest common factor here is 14. So I should be able to do that with numbers or just coefficients. Now we're going to take a look at how I do this with polynomials. So if I'm doing that, what I can do is look at this first question here. So 36x cubed and 28x squared y. Well, I could just look at the numbers individually. So first of all, just start with 36 and 28. So 36 and 28. What's the greatest common factor or the largest number that could be divided evenly out of both of those numbers? Well, I know 6 goes into 36. That doesn't go into 28. 12 doesn't go into 28. The next highest number then is going to be 4. And 4 divides evenly into 28. So the greatest common factor numerically is 4. Now we have to say, look at my variables. And there's a few different ways you could do this. So if I come back, and I'm just going to rewrite this up here. 36x cubed is technically equivalent to 36x times x times x. And 28x squared y is equal to 28x times x times y. I just took those exponents and wrote them out as if they were a repeated multiple. So what I'm asking, so we just already figured out what the greatest common factor between 28 and 36 was. We said that's 4. Now what I need to do is remove the highest number of x's and y's evenly from each group. And so there's 3 x's here and 2 x's here. Well, how many could I remove evenly from each group? and it has to be the least that's in common. So I could remove 2 from here, and I could remove 2 from here evenly, but I can't remove 3 because this one doesn't have 3 as an option. So I could remove 2 x's, like an x and an x, which I would write as x squared. And then how many y's could I remove evenly? Well, there's no y here, and there's a y here, so I can't remove a y evenly from each group. So my greatest common factor here is just 4x squared. Okay, let's take another look at B. So here's 8x squared y and 20x squared y cubed. Now, if you want to write it as a repeated multiple, you can do that, but I usually don't do that all the time. I'll do it for one more question and kind of maybe hope that we can figure things out from there. So 8x times x times y, because this is 8x squared y, and 20x squared y cubed, so x, there's 2 x's and 3 y's. So when I'm going to go try and find out the greatest common factor, first thing I'll do is look at my coefficients. So my coefficients here are 20 and 8. So, 8 doesn't go into 20, 10 doesn't go into both of those numbers, 5 doesn't, so my next possible number is 4. So numerically, the greatest common factor between 8 and 20 is 4. Then I have to look at my coefficients and say how many numbers or how many variables could I remove evenly from each of those terms. Well, there's 2 x's here and 2 x's here. So I could remove that out of evenly from both groups. So I will express that as x squared because I could divide out an x squared from both groups. Now I look at my y's. There's 1 y here and 3 y's here. Well, how many could I remove evenly from each group there? Just 1. And so my greatest common factor is 4x squared y. So what I want you to do is take a second, pause the video, and do question C by yourself on a piece of paper. So try question C by yourself on a paper, pause the video, try that. Okay, hopefully you paused the video. And so let's go take a look at the greatest common factor here. So I always start with my numbers. So what's the greatest common factor between negative 40, negative 20, and 10? What number could divide evenly into all of those? Well, 10 actually goes into all of them. So I could say 10. Now, whether you chose a negative or a positive 10, it doesn't really matter. You could have chose either. Then I'm going to go look at my A's. There are 3 A's here. There are 2 A's here and 1 A here. Well, how many can I remove evenly from each of those? 3, 2, and 1. Well, the most I could have removed evenly from each of those is just going to be 1A. And you could do like a 1 there if you wanted, but you don't have to. Okay? And then I'll go do the same thing with B. There's 2 B's here, 3 B's here, and 2 B's here. So how many could I remove evenly from each of those terms? Well, I could remove at least 2 from both of those terms. So my greatest common factor is 10ab squared. And maybe you had a negative, you removed out a negative. So next one here, D is a little bit trickier, but it leads us into the next type of factoring. And so if I look at this, this is 7 bracket x minus 2 and 12x x minus 2. So they're saying, like, what's the same in both of these? Well, kind of what I want to do is break this down. I'll look at the 7x and the 12x because those are kind of like out front. Those monomials. Well, what's the same? Between 7 and 12x, nothing. The greatest common factor would just be 1. And 1 could always be a greatest common factor if that's the circumstance. But let's take a look at what's after the brackets here. So I have an x minus 2 here and an x minus 2. And so this question shows us that a greatest common factor doesn't always have to be a monomial like we have here. The greatest common factor could be something like this, which is a binomial. So the greatest common factor here is actually x minus 2, which is a binomial. All right. So that's starting, and that's identifying of the greatest common factor. Now what we want to do is be able to identify the greatest common factor and then write that in factored form. And factored form is a way of telling us what things got multiplied together to result in a polynomial. And so to write in factored form, what I need to do is I need to remove the GCF and write what is left. So what you're going to have here, kind of in your factored form, is you're going to have your GCF written out front, and then in brackets, you'd say what's left after you've divided, because that's what removing a GCF is. So take a look at how to write in factored form with GCF. So when I start looking at example number 2, it just says write in factored form. Sometimes the question will just say factor. And they say 20x minus 6. So what I do for myself is to the side, I'm just going to identify, as we did above, what the greatest common factor is. Now I have a polynomial that's, terms written together. I'm just still going to look at them individually. Between 20x and negative 6, well, what's the greatest common factor between 20x and negative 6? So I look at my numerical values first of all. So can 6 go into 20? No. The next factor of 6 would be 3. That doesn't divide evenly into 20. So my greatest common factor is a 2. I can't take out a variable because this term here doesn't have a variable on it. So I couldn't remove evenly an x from each term. So what I'm going to do is remove by dividing the greatest common factor. So I'll divide everything here by the greatest common factor. So when I write it in factored form, I'm going to put it like this. So the GCF will come, and I'll write everything that's left in brackets after I've divided each term by the GCF. So I can follow and say, okay, 20x divided by 2 is going to give me 10x, and negative 6 divided by 2 is going to give me negative 3. And assuming I can't factor any further, that is my answer by factoring by removing the greatest common factor. The nice part about factoring is I can always verify by multiplication. So I would take this to 10x minus 3 and multiply it out. Well, 2 times 10x is 20x, and 2 times negative 3 is negative 6. This and this match, so I know that I factored correctly. Let's take a look at another question. So B, exact same thing. They're saying take this and write it in factored form. So I'm going to start by trying to identify the greatest common factor. So the greatest common factor between 16x to the 4 and 4x squared. So I'll start off with the coefficients. Well, what's the greatest common factor between 16 and 4? Numerically, that's going to be 4. Between x to the 4 and x squared, what could I remove evenly from each of those? Well, there's 4 x's here and 2 x's here. I could remove 2 x's evenly out of both of those terms. And so I'll take what I started with and divide it by the greatest common factor. Now I'll take and have to write it in this form. So the greatest common factor will come to the front, 4x squared, and then I will divide each term by my greatest common factor. And so 16 divided by 4 is 4, and x to the 4 divided by x squared. So that's exponent laws. I need to subtract there. So that would be 4 minus 2, so that's x squared. The second part here, so 4x squared divided by 4x squared. Well, that completely cancels out, but it doesn't cancel out completely. I'm still going to be left with a 1. And so that's my term in factored form after I have removed the greatest common factor. So I would invite you to take a second and pause the video and do the same thing I just did to factor C. Remove the greatest common factor, divide it out, and then say what's left. So take a second for yourself and try that question. Okay, hopefully you tried. So first thing I want to do is identify the GCF, and maybe if you were struggling, once I write the GCF, pause it again and try. So the GCF, I'm going to look at 3 terms individually here. So negative p squared minus 6p cubed and 15p. So numerically between these terms, a 6, a 12, and a 15, I can divide each of those by a 3. You could choose -3 if you want. It doesn't necessarily matter, we'll say, for in this case. Okay, so greatest common factor, let's just say it's a 3. Then between these terms, p squared, p cubed, and p, how many p's could I remove evenly? Well, that would just be 1. So there's my greatest common factor. If you got that, but you didn't write your in factored form, try and pause the video again here and finish in factored form and then compare your answer. So what I should do is take this trinomial and divide it by the greatest common factor. So I'm going to remove that. I can't just get rid of it though, because I want to say, make sure this remains an equality. So I put the 3p to the front and then divide each term by 3p. So -12p squared divided by 3p is going to give p. -6p cubed divided by 3p is a -2. And then p cubed divided by p to the 1, so I'd subtract 3 minus 1, is p squared. And 15p divided by 3p is going to give me a +5, and my p's cancel out. So there is my answer in factored form. And if you're ever unsure, you could just multiply that out, and I should end up with the exact same polynomial. I could also verify by substituting an arbitrary value in for x. I could also verify by graphing, but we haven't really talked about that yet. Okay, one more question here to finish up talking about greatest common factor, and then I will post what I kind of want you to look at for practice in the comments. So what I can do, I'm going to do the same thing here. 7 all times x minus 3, and then 2x x minus 3. And so this is sort of like one of those questions we had up here, where I actually have, looking at the 7 and the 2x, there's not a greatest common factor between those. Well, the greatest common factor is 1, but we won't include that. Here, I actually have a GCF that is a binomial, so x minus 3. So my process will work the same way. Oops, sorry. Every term needs to be divided by that binomial. So that binomial will come to the front. So I have x minus 3 as my GCF in the front. And then I write what's left after each term has been divided by that binomial. And because these are all degrees of 1, what happens is like 7 times by x minus 3 divided by x minus 3, these ones cancel each other out. And so I would, oh, that wasn't supposed to happen. What I would be left with here is a 7 from here, because this is gone, and cancels out with this, so I'm left with a plus 2x. Once I've divided each term by that x minus 3. All right, so that's factoring with a greatest common factor. That's sort of the easiest place that we're going to start, and get consecutively a little bit more difficult for factoring from there. So take a look at the comments for what is going to be for the assigned work. Thank you.